To learn about the fourth experiment of EE2 Electronic Engineering 2 Lab EC291 voltage series feedback amplifier. Today we are going to learn to voltage series feedback amplifier. The aim of this experiment is nothing but to plot the frequency response of a voltage series feedback amplifier and to study the effect of feedback on gain and bandwidth. Alright, now look at the circuit diagram. This is the circuit diagram of voltage series feedback amplifier. You have voltage source, source resistance, coupling capacitor, R1, R2, RE1. Along with that 680 ohm is your RE. Along with there is series connected to 120 ohm. See, bypass capacitor is connected from one terminal of 680 ohm to other terminal of next terminal of your negative terminal of your bypass capacitor. So this is your first stage of your amplifier and this is your second stage of amplifier. So you are going to use a voltage series feedback amplifier with the using of 2BC548 transistor. This is your first stage and this is your second stage. First stage of your output is connected to the input of your second stage, and the output of your second stage has been given to the output. This is your VS and output. And for this circuit is without feedback. Now look at with feedback, the circuit of load resistance from 8 this is 4.7 kilo ohm load resistance is connected back to the first stage of your coupling bypass capacitor. This is now the circuit became as with feedback. Without the output of your second stage is connected back to the bypass capacitor of your first stage. This is your feedback, voltage series feedback amplifier. Now look at my connections on my breadboard. This is my breadboard connection. This connection is without feedback. This connection is without feedback. This is your first stage of your transistor. This is your second stage of your transistor. This is your load shunt capacitor and load resistance which is taken an output. This is a positive. Red one is your positive of your CRO and black one is negative of your CRO. And input is your this is your input source resistance, and DC supply which is given 20 volts, approximately 20 volts to the input of the circuit. Now look at the waveform. Now look at your waveform. This is your input waveform, this is your input waveform, and this is your output waveform. Keeping 1 kHz of frequency, and input is 3 millivolts. This is your 0.5 and 2.62, 5 volts. This is input will be 3 millivolts. This 3 millivolts is toward the constant, and you got an output. This is moving. When I keep it stable, you will get it stable. You could easily calculate the things. Keeping as input, giving input as 3 millivolts at 1 kHz of frequency, you got output as 5 volts. So output by input, you got a gain of 1600 gain. So when you keep logarithm, if 20 log of gain 1600, you will get it 64.4. Now look at my variation of my frequency, 30 Hz, 50 Hz, 80 Hz to 1 MHz of frequency. Now my mid band from 100 Hz to 30K, which is gain is constant from 1600. This is mid band gain. Alright, this is your gain in dBs. So when you are less frequency, gain is been decreases. When high frequency, the gain has been decreased. This table form is nothing but without feedback of voltage series. Now look at this circuit. When I was connected, this output of my load resistance connected back to the bypass capacitor. This circuit will be act as feedback. So I am going to connect right now. The on my breadboard output of my from load resistance is connected back to the my negative of my bypass capacitor. Once I have been connected, now look at my output waveform. Output waveform has been decreased. Now this is without feedback. Now this has been with feedback. This is with feedback. Without feedback is gain is high. With feedback is gain has been decreases. So normally, now look at my waveform. Look at my table form. So when I go 0.2, I have been got. When input 1 kHz of frequency, output voltage I got 0.2. So output 0.2 by divided by 3 millivolts, you will get it something approximately something 0.2 divided by 3 into 10 power of minus 3 will be approximately, it will be equal to 200 2 to the power of 6, 0.2 divided by 3 millivolts. So you get 66.66. So this has been fall down. So when you draw frequency response, this is your mid band range, this is your width feedback, this is mid band, which are at 60, 100 your gain, and this has been reduced to 66.66. Thank you. Continue. Alright, this is circuit is with feedback. Now output is fed back to the input. Now look at your table form. 0.2 you got it in output. 1 kilohertz of frequency into 0.2 into 5, 1 divided by 3 milli will be approximately 333. So now your input, the bandwidth of with feedback is going to increase because it's throughout the constant from 30 Hz to maximum of 1 megahertz. At 0 it will be a 0. At 0 frequency it will be a 0. For high frequency at nearly 2 megahertz it will be approximately nearly 50 of your gain. So thank you.